Yet, I have already shared my screen.
Yeah, that's great. So I think everyone is set. So we are almost ready to go. So we still have 1 minute. Let us just wait one more minute and we start. Okay, so I think we are ready to start. So welcome everyone to the XC session on Search-Based Software Engineering 2. So we will have 6 amazing presentations. Each will take 5 minutes. Then we will have a discussion period. If you have any question, you can either like keep your question at the end of the presentation. You can alternatively write your question in the chat box, or just unmute yourself after the presentation. Ask question. You are particularly encouraged to ask questions to the participants, to the presenters, and also presenters themselves are encouraged to ask questions to other presenters. So we will start with the first, Abdul from Alberta. So I think please go ahead.
All right. Can you hear me?
Yes.
Okay. Hello, everyone. I'm Abdul Ali Bangesh, and I'm a PhD student at the University of Alberta. Today, I'm here to talk about my paper in which I propose a black box technique that can be used to reduce the energy consumption of Android apps. I have done this work in collaboration with Kareem Ali and Abram Hindel. First of all, I would like to talk a bit about the motivation behind my work. Current literature suggests that battery is a huge concern for the smartphone app developers because if an app consumes too much energy, it gets bad user ratings on the App Store, and it gets lesser downloads, and it eventually hurts the profit revenue, and this concerns the developers. So now the developers want to develop energy efficient apps by employing various energy measurement and optimization techniques. For measurement and optimization, there are hardware-based techniques available for the developers, and there are also certain software-based techniques available. However, both of these techniques have certain limitations. The hardware-based techniques are hard to learn, they are hard to set up, and are cost ineffective. Alternatively, there are software-based techniques available, but for these techniques, developers have to root their phones and generate and execute test cases to collect dynamic traces. As a solution, we investigate if we can optimize the energy consumption of an app during the Android compilation process. First, I would explain how the Android compilation process works. The source code written in Java is compiled by the Java compiler into a Java bytecode. Then an optimizer performs bytecode level transformations to further optimize the bytecode. After that, a DEX compiler converts bytecode classes into DEX bytecode. And finally, an Android APK manager packages this bytecode into an Android executable format, that is APK. We investigate if the bytecode level transformation that the optimizer performs can affect the energy consumption or not. To investigate the effects of bytecode transformation on energy consumption, we consider a random set of 4 bytecode level transformations that were initially written to reduce the app size and improve runtime performance. When we applied these transformations on 22 real-world apps, they reduced the energy consumption of 12 out of 22 apps by up to 1.24%. To further investigate, we use the Facebook's Redux bytecode transformation framework, which is written on top of ProGuard. This framework offers 17 transformations that are mainly written to reduce the app size and improve runtime performance. Some of the transformations out of these 17 are constant propagation, dead code elimination, method inlining, and so on. However, for applying 17 transformations on an Android app, we have to consider all of their possible combinations. That means 2 power 17 possible solutions. It is exhaustive to measure the energy consumption of 2 power 17 solutions variants to find the best variant. Hence, applying all possible combinations of 17 transformations is impractical. As a solution, we explore the search space of 2 power 17 possible solutions using genetic search. Initially, we randomly select transformation combinations to generate an initial population of solutions. We then measure the solution's energy consumption to select the most energy efficient solutions from the search space. After that, we apply crossover and mutation among the best transformations for the next iteration. We keep repeating this process for 10 iterations if the solution stops improving, and for 20 iterations at max. At the end of this process, we get the most energy efficient transformed version of the original Android app. We applied this technique on 4 real-world apps to evaluate its effectiveness and saved up to 11.05% energy among 2048 game, 1.15% reduction in Chrome browser, 0.42% reduction in Anagram utility app, and 1.79% reduction in the Paint utility. In conclusion, I would say that developers want to develop energy-efficient apps, but there are several limitations in the current techniques. As a solution, we propose a black box technique that developers can use to reduce the energy consumption of their code. When applied on real-world apps, our technique reduced up to 11% energy consumption. In future, we want to investigate about the reasons behind the bytecode transformations that led to energy reduction. We want to apply a multi-objective optimization technique to reduce app size, improve runtime performance, and also reduce energy consumption simultaneously. And using the current studies dataset, we want to train a prediction model so that we can predict the best combination of transformation that can be applied on a certain Android app. That's all. Thanks a lot for listening.
Okay, thank you very much, Abdul, for this very. So now we will move to the next presentation titled Fairness-Aware Configuration of Machine Learning Libraries by Saeed. So Saeed, please go ahead.
Just 1 second. Okay.
Hello everyone. Today I'm going to talk about fairness-aware configuration of machine learning libraries. Data-driven software is growing fast and has pervasively applied in critical domains such as self-driving car and socially critical applications. They have been using criminal justice to make parole decisions, in hiring to filter out candidates, and for various risk assessments. Since these applications learn their logic based on historical data, they are prone to fairness bugs. Therefore, it is critical to ensure fairness in such application for compliance and inclusion. These data-driven software often provide interface to programmers to interact with core machine learning libraries such as scikit-learn to feed input dataset, as well as configure machine learning algorithms with suitable hyperparameters. Hyperparameters include the number of layers and neurons in deep learning, the number of depths in the decision trees, and the number of clusters in algorithms such as k-means. These papers study the relationship between hyperparameter selection and fairness. We answered 4 research questions that I'm posing right now. Whether hyperparameters affect the fairness of data-driven software. That's research question 1. Research question 2 studied whether principled search-based software engineering can help us find interesting inputs. Research question 3 study whether statistical debugging can help us understand the rule of hyperparameters. And finally, research question 4 compare our approach to the state of the art for mitigation. To answer this question, we propose a two-step method. First, we use an evolutionary algorithm based on mutation operators to search the space of hyperparameters and characterize the accuracy fairness frontiers of hyperparameter. Then we use statistical fault localization to explain what hyperparameters are similar in the fair models and what hyperparameters distinguish biased model from fair ones. To overview our approach, let's consider random forest ensemble with 18 hyperparameters, such as the max depths of the tree, and a data set of adult census income that predicts whether an individual has an income over 50K or not. We use sex as a sensitive attribute first. We run our search algorithm for 4 hours and characterize the inputs. We measure fairness based on EOD, which is equal opportunity differences. And basically, it is the differences in true positive rate of two groups, in this case, male versus female. And we consider overall accuracy. So we wanted to know, using decision tree, are there any hyperparameters that achieve similar accuracy, but their fairness metric is different? We did the same experiment using race and generate the input and explain the differences between two clusters of the fairness inputs based on the decision tree. The phenomenon was that mean weight fraction leaf that restrict the number of sample in the leaf node of decision tree or random forest can negatively impact fairness if it sets to value greater than 0. And max feature, which restrict the maximum number of features to search during training, can also negatively impact fairness if it sets to square root or log2 base a number of the features. Now, after overviewing our approach, let's come back to research question 1. We found that indeed tuning hyperparameters impact fairness. Within a 1% of accuracy margin, fairness can be below 1% or above 23% based on the hyperparameter tuning. In research question 2, we found that a classical search-based algorithm such as evolutionary mutation-based is effective and outperform random search or grid search. And research question 3 found that decision trees are useful. We analyze over 900 decision tree models and provide intuitive explanation if any hyperparameter systematically influence fairness. Finally, research question 4 found that our approach can be also used as a bias mitigation method, and it can complement existing methods to achieve even better fairness. This is end of my talk. Thank you for listening. The tool is available in the following GitHub repository, and it's already received badges from Artifact Evaluation community. Thank you.
Thank you very much, Said, for this very nice presentation.
Thank you.
So let us move to the next presentation that will be titled Unleashing the Power of Compiler Intermediate Representation to Enhance Neural Program Embeddings by Zhongji Li. I hope I'm pronouncing well your name.
Yeah.
That's great. So please go ahead, share your screen.
Yeah. So hello everyone, I'm Zhongji Li, and today I'm going to talk about the paper Unleash the Power of Compiler Intermediate Representation to Enhance Neural Programming Embeddings. So the first background is about neural program embedding. So since nowadays there are a lot of tasks like code identification, program repair, and code completion. They all use the deep learning model, and a basic pipeline of this model is to given the input source code for test training or test, and we get the input representation, and after the model, we get a numeric vector. And the second thing is about LLVM structure. So basically, it's like GCC, and you can treat it like GCC, but it's more modern and more popular nowadays. So, and one of the serious thing is that LLVM got a lot of passes more than 500 passes, and it is still increasing, including like what I show here, like the dead code elimination and so on. But some of them are verified passes. That means they basically do nothing but verify. So they will they won't change the code very much. And some passes are platform specific. That means they target on a special kind of platform. So how to select the suitable passes to boost the performance? Our approach is to use a genetic algorithm. First, we will have some data set, and we select some of them to be validation data set, and we compile it into different IR files. And with the fitness function, which is made of OV ratio, auto-vocabulary ratio, and CFG similarity, we will decide whether it gain a good score or not. And after that, we will do the modification and selection. And finally, we will find the top K best IR sequence. So we will use this IR sequence to train the model with the source code. And here is the main structure of another CoCMR, which is we use. So for the experimental results, we choose some baselines, including CodeBERT, this kind of pre-trained model. And we found that the CoCMR before augmented performs not very well, but after the augmented, it outperforms all the settings. So our conclusion is that we first advocate the use of compiler optimization for software embedding augmentation, and we build IRGen, a practical tool that use genetic algorithm to find the near optimal optimization sequences. And our evaluation demonstrates that our method works. So yeah, so I think that's the end of my topic. Thank you very much.
Okay, thank you very much, Zongji, for this very nice presentation. So next we have the paper titled Control Parameters Considered Harmful, Detecting Range Specification Bugs in Drone Configuration Modules via Learning Guided Search, that will be presented by Huidong Han from Xidan University. I hope I'm also pronouncing correctly names and university. So please go ahead.
Yeah, that's right. I will share my screen.
See your screen.
All right. Hello, everyone. My name is Huidong Han.
Can you
University.
make full screen, Huidong?
Yeah.
Because we see your PowerPoint and your notes. So.
Where? Strange. In my screen, it's for screen style.
So we only see your PowerPoint. You need to.
I'll try again.
I think this is a bug, right? So you can just convert it into PDF and use Chrome to presentation.
It's full screen.
Oh,
Yes,
yeah.
now it's full screen. Yeah, that's
Okay.
great.
Hello. Hello everyone. My name is Huidong Han from Xidan University, and today the topic of my presentation is detecting range significant bugs in joint configuration models. We are learning guide search. So first, I will explain what is configuration parameters joint and what will it influence take as a example to adapt to different equipment and operation environments. Drone control program always provides various parameters to adjust, and it also provides value range guideline. Users set the configuration according to their requirement. For instance, for angel max in document, which is to adjust the max angel during flight, it ranges from 1 to 8,000, which is 10 degrees to 80 degrees. If I want to fly faster, the value should be larger. However, the function of adjusting parameters introduced a problem that lack of adequate checking for those values. Specifically, some configurations within the range will trigger unstable flight states, deviation, or even drone crash. For user, they often refer to the official range limitation and may upload those configurations to cause serious consequence. Besides, attacker can also use this feature to create their attack. They can cause a drone to have a problem by sending those configurations. So, to protect this issue and make user safety configure the drone, we propose our system, a fuzzing test system, to discover this configuration and generate. This system consists of 3 components. Is to predict the flight states and assess whether configuration will lead to unstable states. And the searcher is a genetic algorithm model to carry out the fuzzing search. And finally, is an estimator to provide a parameter range guideline. The key idea of is in this part, we use a probability-based predictor to replace the actual running validation as a feedback. So the fuzzing process becomes change configuration and evaluation, feedback, continuous change, and so on. Through the continuous iteration, our system search out those configurations with a higher probability of causing unstable flights. And referring to these configurations, we summarize a suitable guideline for users. The principle of our predictor is to simulate the control process of the drone. The model predicts the next desired attitude based on the current stance and the specific configuration. Without configuration changing, the actual next attitude should be very close to the desired value. On the contrary, if an inappropriate configuration is set, it will make the deviation be larger. The predictor system is to help the genetic algorithm to find more inappropriate configuration. So that's all my presentation. Thank you for your listening.
Thank you very much, Ruben, for this very nice presentation. So let us go next presentation, which is titled Search-Based Diverse Sampling from Real-World Software Product Lines, that will be presented by Yi Zhang from South China University of Technology.
Okay, right. I'm going to share my screen. All right. Okay. Okay. Yeah, it's okay.
Yeah, great. Please go
okay.
ahead.
Excellent. All right. Okay. So, yeah, today I would like to talk about a work which is about diversifying a set of samples from a real-world software production lines. Okay. So my name is Michin Lee. I'm from University of Birmingham, UK. So the software production line, or SPL, refers to software engineering method to create similar software products or configurations from a common set of features called feature model. And the large real-world SPLs often encompass thousands or tens of thousands of features. So the configuration space could be prohibitively large. So in this case, we can't do an exhaustive search. We can't consider all the possible configurations. So we need to sample a set of representative configurations. So given that, so in this work, we focus on diversifying sampled configurations with respect to the number of selected features. Okay, so the one question is, why the number of selected features? Why this specific thing matters? Okay, the reason for that is we find is that presumed diversity in terms of the number of features in sampled configurations can directly improve the accuracy of performance prediction. But unfortunately, existing samplers struggle in diversifying samplers. For example, the uniform samplers SMARC and Unigine 3 can't provide a set of diversified samples. Here, as we can see in this figure, the samples of SMARC and Unigine concentrate in a small region of the space. Okay, so in this case, our work follows a recently developed diverse sampler, DDBS. So DDBS is a very good sampler focused on diversifying the samples. Okay, but the problem of the method is the scalability. So that is the ability to solve the problem with much more features. And it turns out when the number of features is more than 100, DDBS will not be able to find a solution. Okay, so then what we do here, basically we use a search-based algorithm and we consider two things. First of all, we consider when generate initial solutions. Okay, we use efficient off-the-shelf set solvers. Okay, so this can enable us to find valid solutions. Secondly, and more importantly, and we use novelty search to iteratively improve the diversity of sample set. Okay, so what is novelty search? The novelty search is a type of evolutionary algorithms in which there is no objective function, but rather a novelty score trying to maximize the dissimilarity between the solutions in the population. So in the novelty search, we don't have an objective function. We don't need to optimize or try to minimize a cost or maximize something. But here we have a novelty score. We're trying to maximize the dissimilarity between the solutions in the population. Okay. So in our case, we consider dissimilarity between configurations in terms of the numbers of their features. Okay, so I won't go to the technical details. I just show some results. Okay, here we consider 39 feature models, and we can see some feature models have a large scale, which have 60,000 features something. Right. So then we compare our algorithm and SPS with 4 state-of-the-art. They are a SAT-based sampler, DDBS, which is a diverse sampler, Unigine 3, and SMART. Okay, and we can see from the table, so like DDBS, our algorithm performs significantly better than the other 3 methods. So this is about effectiveness. In terms of efficiency, and we can see for the DDBS can't find the solutions for many cases. Actually, when the number of the features is greater than 100, then the DDBS cannot find a solution within 1 hour. And in the contrast, our algorithm and the SAT-based sampler can find the solutions for all the cases, for all feature models. So this suggests that our algorithm can strike a good balance between effectiveness and efficiency. Like DDBS, we can produce diversified samples, and like SAT-based sampler can to find the solutions for all the cases, even some cases where the number of the features is greater than 60,000. Okay, that's all for it. Thank you.
Okay, thank you very much, Ming Li, for this wonderful presentation. So we are almost at the end of presentation. So we will have the last one, the last presentation titled Code Search Based Contextual Code Translation. This will be presented by Wei-Song Sun from State Key Laboratory of Novel Software Technology, Nanjing University. Please go ahead. Wei-Song, do you hear us? Can you unmute yourself? Okay, now we hear you. We can see also. Go ahead.
Okay, hello everyone. Welcome to my talk. I'm Wei-Song Sun, a PhD student from Nanjing University. It's my honor to have this opportunity to introduce our XC work, code search based on context-aware code. I first introduced my motivation and background. Software development is usually a repetitive task. That developers tend to search for high-quality implementations for reference or reuse. Here is an example of code search. In general, the query is usually a short natural language sentence describing the functionality of the desired code sleeve. The code sleeve is a programming language function that satisfies the developer's requirements. Existing work can be categorized into traditional methods and deep learning-based methods. Traditional methods simply treat queries and code sleeves as plain text and retrieve code sleeves by only looking at matched keywords. They fail to capture the semantics of both query and code sleeves. Deep learning methods transform input queries and code sleeves into a unified vector space and find code sleeves by linking the cosine similarities between query and code embeddings. In this work, we focus on the development. However, performance of existing deep learning methods is still limited due to the insufficiency of encoding semantics and embedding discrepancy between queries and code sleeves. For example, the code sleeve SA and SB use for and while statements for the same semantic to loop over all elements in the array and add their value into a variable. However, from the abstract syntax trees, we can observe that the subtrees circled in dotted lines are different for them. Such representations cause inconsistency of code semantics. Control flow graph is also commonly used for representing code slips. The code slip SE is to calculate the sum of a given array, while S1 is to calculate the factorial of a given number. They have completely different goals. We generate the control flow graphs for them. We can observe that the two control flow graphs have the same graph structure, which cannot differentiate the semantic difference between them. This example indicates the insufficiency of utilizing control flow graphs for representing code semantics. Okay, next I introduce our approach chunks. This figure shows overview of our approach. The top part shows the training procedure of chunks, which consists of two stages: context-aware code translation and model training. The bottom part shows the usage of chunks for a given query. It's a common practice to use comments of code slips as queries to training model. In this paper, we aim to build a homogeneous representation between queries and code slips, which can better capture the shared semantic information of these two types. Context-aware code translation is the component of chunks, which implements code translation through two steps: instruction generation and instruction translation. In instruction generation, chunks takes in code slips and produce their instruction sequences. In instruction translation, chunks takes in instruction sequences and produces their natural language descriptions according to predefined translation rules. Translation rules are constructed manually based on instructions, operations, and descriptions from the virtual machine specification. An operation is a short natural language description of an instruction. For example, the instruction iStore operation is this one. From this operation, we can know that the behavior of iStore is to value into a local variable. A description is a long natural language description of an instruction, which details instruction interaction of the instruction on the local variables and operand stack. For example, iStore's description is this one. From this description, we can know that iStore first pops an int value from the operand stack and then stores the value into indexes position of the local variable. If we only use the operation as the instruction translation, such translation will be inaccurate due to the loss of some important context. If we only use the description as the instruction translation, such translation will be too long. However, research in the field of NLP reminds us that capturing the semantics of long text is more difficult than short text. Based on the above, we strive to make the instruction translation short and context preserving. Therefore, we use the operation as the basis, combining the context specified in the description to manually collate a translation for each instruction. For example, a translation rule for instruction iStore is this one, where PS and PV denote placeholders that specifies the position where the context will be filled. The context of instruction consists of constants, local variables, and data and control dependencies with other instructions. Constants, local variables, and control dependencies are directly determined by operands. An OP code is followed by 0 or more operands. An operand can be a constant or an index of local variable. or an index of instruction. Data dependencies between instructions are implicitly passed through the operator stack. Figure B shows the changes of the operator stack when the opcode sequence in Figure A interacts with the operator stack. The values in the operator stack are the carriers that reflect data.
Hello, everyone. So I think we are done with Wei Sang-san. Are you still here? Maybe we lost him, right? So maybe he was at the end of the presentation. So yeah, if he's not here, maybe it's time to go to questions. So please, if you have any question, feel free to ask. For any paper, we don't have any specific order for questions. Same also for presenters. You can ask other presenters. Please feel free to ask questions.
Maybe I want to ask some questions for the last presenter. So
Yes, please go ahead.
yes, in paper to generate the translation rules, the operation and description in Java. When I see document, there may exist two instructions have a same operation. Istone underscore. So will it affect the generation?
Wei Sang-san, do you hear us? I think he left. I cannot see him in the list of attendees. I think he had an internet issue, maybe. I'm not sure. Wei Sang-san, can you turn on your microphone? Wei Sang-san?
Maybe they get some trouble.
Yeah, I think he has trouble with his internet connection, but in the meantime, we can move on to some other questions and we get back to your question later on when we figure this out.
Okay, I have a for Han on AutoPilot. I was wondering, how do you handle non-determinism in your fuzzing? Oh.
So question for which of the papers?
Yeah, I think for the third paper with Han, if I'm spelling right. Yeah.
Okay, I'm here. Could you please repeat your question?
Sure. I was wondering, how do you handle the non-determinism or probabilistic feedback that you are receiving during the fuzzing?
I can't hear you clearly.
Yeah, okay. I mean, you have some non-determinism, right, in your feedback?
Yes.
Yes. Like fuzzing, as far as I know, mostly works on deterministic case, but with same input, if you are receiving two different feedback, how do you handle that? Like, just to understand a little bit more.
Okay, I will explain what is work, how it works, and for individual that was a configuration in my genetic algorithm. So if a new individual is generated, we input it into the predictor to generate a probability score that show how this configuration will cause unstable states according to the model prediction. And if we get a score, we feed back to the genetic algorithm to tell it how to invoke the next generation. Is it clear?
Sure. Yeah. Thank you.
Hello?
You are muted.
Sorry, I was muted. So thank you for both of you for the response and for the question as well. Any other questions? Please go ahead for any of the authors or any of the presenters.
Can you hear me?
Yes.
Yeah, I want to ask a question to Syed.
Yes, go ahead.
Yeah.
I'm here.
Okay, so my question is, you mentioned that you consider evolutionary mutated-based search. So what is that? It's a evolutionary mutated-based search. Is something you didn't consider crossover or something just or a new algorithm or something like that?
Yeah, I think there is different name in different community. I consider what in called in gray box fuzzing as an evolutionary algorithm. So yes, the population, the individual and the population, we call C, they are independent. So
Okay, independent.
yes, independent.
Yeah, because I noticed some version in the evolutionary communication we called evolution strategy. So which doesn't consider a crossover, we purely use mutation. So I just wondering what's the difference between your algorithm from theirs, from this evolution strategy.
Yes, I'm not 100% sure, so I will maybe follow up with you to understand evolutionary strategy like things. But here, evolutionary strategy is whether this input is an interesting. For example, whether this input visit a new path in the program, or whether it leads to higher bias or higher or lower bias during the search. So we add those as an interesting input to population and use them to further mutate them with some mutation strategies.
So how big is the population?
Population depending on the application. I think I don't remember exactly the number, but it's about 1,000. But it can go to a few thousands, I guess.
Okay, I see. Okay, thank you.
Thank you.
Okay, thank you. Any other questions? Maybe I can have one question to Wudong Han. So here you are like working on specification bugs in drone configuration modules. So this is something new for me. I'm wondering how large are configuration files or configuration modules in drone-based applications as compared to other production files? Do we expect like a lot of files, or this is just small part of the whole system?
Sorry, now may get some trouble. Could you please repeat your question?
Yeah, so this is I like your work on specification bugs in drone configuration modules, and this is something new for me. I'm wondering how large are these configuration files or modules as compared to other production files, and how hard is it to find issues in these files?
All right. In our experiment, finally search out over 2,000 tables configuration, and over 80% of them cause the real problem simulation situation, and we asked about 100 configuration in the real world, and there are several of them cause a real problem, like I showed in the YouTube links, making some deviation and frozen around, and even a crash.
Yeah, and what programming language for this kind of programs, and also for production and configuration? Are there any specific languages that you use?
Sorry, I just hear what program language is we use, and we write the whole software with Python, and to use the common deep learning modules and genetic algorithm, and the output is a configuration of the primitive values, and when we test these values, we set it in the draw star emission flight.
Okay, thank you very much for your response. Any other questions or comments, suggestions? We still have 8 minutes.
Hi, hello. Again, so may I ask a question about Abdul's work?
Yes, please go ahead.
So, in your work, you mentioned you consider genetic algorithm, which you consider 10 or 20 generations. So, I just wondering, so why this setting?
The sim work in our work.
Sorry, it's not your work. Sorry, it's Abdul's black box.
Sorry.
Yeah, Abdul's first presentation, the very first presentation.
He mentioned that he had some problem with his voice, and I remember. And if you can send it to chat, but I see that you already did. So.
Okay, Abdul,
Okay.
he put
No
something
worries.
on the chat. Oh, okay. So, okay. So I see there are many questions in the chat. Okay. So, yeah, maybe Abdul, do you hear us? No. So maybe in the meantime, tell Abdul, can you write your question in the chat box? Maybe you can have an answer there. And in the meantime, let me have another question to Said. So you use like evolutionary algorithms for configuration of machine learning libraries, and then also, I mean, when we adopt or when we use evolutionary algorithms themselves, they need configuration. I'm wondering how to do the configuration of these algorithms as well. So it's kind of recursive problem in this case. Do you have any like thoughts or suggestions in this situation?
To use them, sorry, in in my problem or beyond that in general software configuration?
Yeah, maybe first for your suggestions in general.
Sure, yeah. I think like I generally found out that even for hyperparameter tuning is generally challenging in machine learning domain. So various people like propose various techniques. Like they sometimes use grid search, but in general they suggest to use random search to randomly basically explore the space. So in this work, we found that evolutionary algorithm can actually achieve better results. So it can actually approximate the curve of accuracy versus fairness very efficiently and show the high bias and low bias models compared to like random search and also other multi-objective evolutionary algorithm. We compare one that was Flash. That is the like main insight, but in general, I think there's two ways to do this. Like some people like consider multiple objective as their cost function. I call it here evolutionary algorithm. But some people also like formulate this as a constraint. So in this work, we found that this formulating as a constraint instead of having a multi-objective model worked well in practice compared to them. So yeah, I think some of this algorithm might be also useful for software configuration in general. So at least one work that performance configuration of the Java software in general can also benefit for this, but also in fairness setting, fairness of machine learning and data-driven models, it might be also useful. And in addition, there are some kind of limitations, such as how we use feedback from program internals and so on. We limitedly explored those, but there's opportunity to do better instrumentation in lower level libraries and obtain more feedback during the search. So that's a little bit open problem right now.
Yeah, thank you very much, Said. But my question was about the use of evolutionary algorithms needs configuration as well, not only machine learning. So I'm wondering, when you try to find the right configuration or the best configuration for fairness in machine learning, what kind of configurations you do for these evolutionary algorithms to converge towards the best solutions that you want to find for configuring machine learning?
I see. So the algorithm algorithm parameters itself. So you are asking like what are the okay, let me
I mean, this is a recursive problem, right?
Yes. Maybe I can mention that like some of the choices are like what is the interesting inputs, whether it is AOD, like the metrics that you use as something to distinguish interesting and non-interesting input. That might be one metric. That's a little bit configuration of your algorithm. And then the size of your population, like you want to grow up, like consider everything, or you want to like limit that. So that's another constraint. And the other one is the accuracy choice, whether you want to filter out, only consider the models that achieve like 80% accuracy. So those are like some parameters that I can recall, but didn't have that many to mention, to be honest. But is that answered your question? Sorry.
Thank you very much for Said and for sharing with us your experience or expertise with this field. Any other questions? You still have 1-2 minutes. I mean, this is your unique opportunity to ask questions. Yeah, otherwise, if there are no more questions, let me thank all the speakers and the participants to this session, and wishing you also good luck with the remaining sessions of ICSE 2022. Thank you very much, everyone.
Really.